Yeah, so now we go to the second talk with Damjan. And yeah.
Thanks a lot. So, hi, my name is Damjan. I'm the head of technology at Posedio. So we as a company are a relatively young company, started 3-4 years ago. Yeah, we do mostly cloud-native development. So you might have seen us around. Also, I see some KCD Austria shirts. So at the last KCD. Yeah, we do software engineering, we do infrastructure setup, DevOps, so the whole kind of breadth of services in the cloud-native space. Myself, I started my career as a software engineer, so I studied at the TU Wien, moved to Vienna 2012, originally from Macedonia. Then I got kind of into full stack development, so initially Java backend, then full stack with some React TypeScript. Then moved on to kind of DevOps topics, platform engineering, Kubernetes, then Google Cloud, and now I am mostly involved in building a data platform, so platform engineering and data engineering. I have worked on a couple of large-scale projects in the cloud-native space. So one of them is one of the largest transaction processing services in Austria. If you're interested what it is, we can talk later, not on audio. And another one is one of the bigger developer platforms, so internal developer platforms for the same company. Throughout this whole process, I've really enjoyed looking at the security aspect of this whole cloud-native space, especially since it's so much different to what was back in the day considered security, and so much different from the advice that you got from the people that worked really with perimeter security, network security, and all of these things are kind of new for them and a bit yeah, different. And for me as a starter, then it was interesting to see the contrasting advice from people who were like, yeah, you put a firewall, you're done, and people who would tell you you're never safe and you have to really be careful at every step. So the goal for today for me would be to talk about how can we build secure systems. I will go over like just a brief overview of the old school perimeter security. Hopefully we will see why this is not enough, especially in cloud-native systems, in modern microservices. Then I will try to establish like a basic vocabulary for security, what we're looking for, what is a secure system. Then I plan to go over some tools, open source tools mostly, that can be used to secure your systems. And finally, I will give some examples of services or systems that we have built where I believe we've paid special attention, special care to have the security done properly, even though you can never be fully secure. Of course, it's a bit tricky for me to estimate the knowledge level in the room. So if you feel that I'm going too slow or some things are, yeah, you know them already, just someone raise a hand, tell me to speed up. If you would like to spend a bit more time on some topics, especially some of the tools, which I find very cool, let me know, we can go into more details, maybe draw some stuff, let's see. So first, security the old way. Yeah, back in the day, life was simple. You had your backend, you had your database, you were happy. Of course, a backend and a database is not very useful. At the very least, you need a user that actually uses this backend. And once you have a user wants to have a bit of a nicer UI, so you put some front end in place. And front end, especially with the modern React, Angular, Vue.js, and so on, you want to have your server that serves the front end, and then you have the assets, the JavaScript, the HTML code somewhere in storage. And then somebody says, yeah, but I need admin access to the backend because I want to configure the backend and I want to make some changes there. And of course, then you have your developer that has direct access to the backend because the developer uses a command line tool. They don't need fancy UI. And you have the user from the browser accessing this backend directly. Then someone comes along, says, well, maybe we can have some load balancing, or maybe we can have some gateway in between to make sure that the access doesn't go straight to the backend and straight to the database. And at this point, you're already starting to discuss security. So do we give access directly? What do we put in between? How do we deal with this? And the traditional way to deal with this was to basically segment this. So say, okay, this part is public. It can be accessed from the internet. Then we have our private part. We want to keep these things private. And obviously, only this kind of gateway in between the public and the private is able to call the backend service. Of course, our developer, private VPN, top-notch security. And then we have the persistence, so the crown jewel. This is where we say, okay, this is where our data is and what is very important for us. And here we basically allow no one. If we are being realistic, that guy would also have an arrow to the database, but let's not talk about those things. And then you say, okay, we have our splits, so we want to compartmentalize. This is what will be our solution. So we put the internet and the DMZ. The DMZ we say, so traditionally called demilitarized zone. We say in the DMZ we need to make sure that we have access control, that we have security, that we have checks. And then we have the DMZ and private zone. And in the private zone we say, okay, only the DMZ is allowed to talk to the private zone. Therefore, anything goes there because no one from outside, no one mean could talk to our private zone. And obviously, even back then, this was a kind of, yeah, let's say, interesting approach. But today, it clearly doesn't work. So if you look at like microservices and how systems work, you have so many services. You have, especially in the cloud-native space, services that are constantly changing where they are, who they are, what they do. You have so many users that you simply cannot use this concept to simplify the security. So the whole idea of why this existed was because it allowed you as a developer to simplify the concept of security by a lot. So you say, I focus all my efforts on the front, and then I consider the private part really private, and there I don't need to invest as much time. But if you think about cloud native, where IPs change all the time, then you cannot really know what is private, what is public, because you cannot have a segment of IPs, not easily, where you say, this will be my private services, and then they will only be accessible from these IPs, which used to be dedicated servers, which used to be dedicated applications, and say this is the only way the communication happens. To be clear, I'm not saying that there is no value in network segmentation. I'm not saying that you shouldn't have firewall rules. I'm just saying don't rely only on firewall rules. So this is why Zero Trust, as the topic of the title, is also kind of this trust but verify. So the idea is not that you don't trust anyone, and it's not that you trust everything in the zone. It's somewhere in between. So the idea is that every time a request comes in, you need to verify and make sure that this is authenticated and authorized. But I talked a lot about authentication, authorization, IPs, identities, so on. So I want to establish some like ground rules on what is security and what are the terms that I'm using today. I guess all of you have already seen this kind of CIA triad, it's called. So the general idea is that you have this confidentiality, availability, integrity, and this is considered to be kind of the main pillars of security, of information security. Why are the three important? Obviously, confidentiality. It means that people cannot read or see data that they're not allowed to see. Private data stays private. But there's also integrity, which means people cannot change the data that they're not allowed to change, which is obviously very important in order to make sure that, nobody, I don't know, adds 10,000 euros on their bank account when they're not allowed to. Availability is a bit trickier in the sense that it's not always considered to be a part of security. Traditionally, availability is more like an uptime and so on. But if you think about it, if your service is not available, if it's not there, it cannot be used. That means that confidentiality, integrity doesn't matter. So when we talk about security, what we want to make sure is that no one that is not allowed to use the service can use the service, but we also want to make sure that everyone that is allowed to use the service can use the service. So once we have these terms like integrity, availability, confidentiality, how do we make it happen? There's the famous AAA. So I know it as authentication, authorization, auditing. Accounting, I guess, works just as well. The idea is authentication means confirming the identity of someone. Authorization means checking what they're allowed to do. this has to come after the authentication. Obviously, you cannot know what someone is allowed to do unless you know who they are. And finally, accounting or auditing is the last step. It's actually keeping track of what they have done. So to make sure that no one has done anything that they're not allowed to do, we want to keep track of who accessed which resource, what they did with it, and make sure that they cannot change these records so that they cannot say, oh no, it wasn't me that did this. Obviously, this is a bit tricky, but it kind of plays back into the whole confidentiality, integrity, and availability thing. And it's very tricky to also look at or think of it as three separate things. But I'll give you an example of why authentication and authorization needs to be considered at every point. So we had, in one case, an application where we were pretty sure that, so it was a Google service, where we were pretty sure that Google would, so they said we handle authentication for you, all good. We're pretty sure that we're safe. Only people from our company domain can actually log in and do something, access the service. Turns out when Google meant authentication, they really meant only this authentication part. So if you had a Gmail address, you were allowed to use the service. Because they said we don't do authorization, we just confirm, and you can trust that the user is who they say they are. What they're allowed to do is your business. Luckily, it wasn't the end of the world. Back then, we had an API key in addition, and then immediately we implemented some safeguards in place, so proper authorization on our end. But it's important to keep this in mind also when you go through documentations, also when you go through, especially these smart docs where people write this term where they assume that everyone is on the same page, they know what this term means. Please pay attention, make sure that you're getting what you're actually asking for. The next step for me, what I will kind of approach on this talk is this root of trust. So in order to be able to do anything in computer systems or in life in general, you have to trust someone. The problem is, how do you decide what you trust? So if you say, okay, for a user to authenticate to my system, they need a password. Then the question becomes, how do they get this password? And then you say, okay, I don't know, send them the password via a password manager. Then the question is, do you trust the password manager? How do they get the password manager? Do they install the password manager? How do they do that? So it's really turtles all the way down. So it's like build on top of trust. And in the end, it's a question of risk acceptance. So usually the person or the company needs to make a decision and say, at this point, it's enough for me. I trust that, I don't know, the hardware that I bought is not infected with malware, so I will just trust that and build on top of that. Whether you say I trust passwords from people, or you say I trust the hardware, or you say, I don't know, I build my own hardware from parts, it's up to you. It's a question of risk and a question of what kind of information you're trying to protect. But at the end of the day, this is a real problem. And there is a very interesting scientific paper about it, or it's an address from an award from one of the famous developers of the 70s, which basically proves that you cannot really trust any software because at the end of the day, you cannot trust the compiler it was compiled with. And even if you compile your own compiler, you cannot trust that compiler and so on. So it's really like all the way down. If you get into it, you realize nothing is secure, nothing is safe, and we're anyway hopeless, but at least we do our best.
Why even try?
We try because the alternative is worse, because we don't want to make it easy for the adversaries. The final topic I have for today, which I think is important to differentiate, is the identity. So for me, it's important to kind of differentiate between human identity, machine identity, and workload identity, because this kind of impacts how we make some decisions when we design our systems. And human identity, pretty clear. It's an employee, a colleague, it's a user on the internet, a customer. The life cycle is much different, and the way that you establish trust and what kind of potential security measures you have are different from machine and workload identities. On the other hand, very often you have machine-to-machine communication, and there you have to rely on machine identity. So essentially, if you have batch jobs overnight, usually these run in the name of a machine, and you want to make sure that this machine identity or workload identity exists. So if you think about what I mentioned earlier with the network perimeter and the firewall rules, essentially the IPs were the machine identity. So you had an IP, the IP was bound to a machine, that machine had an identity, there was a system administrator that would assign IPs to machines if they were virtual machines, and this was essentially the root of trust. So the system administrator said, that's the machine, there was a nice Excel, that machine, that IP, that firewall rule, you can trust that. And this is how the systems work, and this is why firewalls and perimeter security work. The problem is, when we talk about microservices, we're kind of moving tracked who made the changes, why were the changes made, and so on. It decouples the execution of the policy, which happens in the open policy agent, which can be centralized or it can be deployed as a sidecar to your services, or can be integrated, so it can also be a library as part of some deployment, as part of a service. And it decouples the auditing part, so every time a decision is made, open policy can actually make a call to an audit repository and then log the decision together with the parameters that it had at the time. Very useful in case you want to kind of externalize this decision-making and authorization process from your applications. Is also useful for other things, for example, for testing Terraform code. There is another approach to authorization. I find this really cool. I learned about it recently. So essentially, this is based on the Google Zanzibar paper. It's how Google internally does permissions. It's the whole GCP IAM is based on that. And this SpiceDB is an open source version of, or similar implementation of this Zanzibar paper. So the paper is public. You can look it up. It's actually pretty cool. Essentially, what they say is they try to build up every relationship in the cluster through a namespace. I'm not sure if we can zoom in here, but no. A namespace, a relation, so an object, a relationship, and a permission. And essentially what you can do is build then a graph that outlines how you can get from a user or an entity through certain permissions, also with some conditions, to an object, to a resource. So you can do things like very simple things like, I don't know, I want to be a reader of a document, and then if I'm the creator, I'm also the reader, so you have some inheritance. And if I give a group permission, then everyone in that group has permissions, but if I give a person permission, then only that person has permission. But you can also do some very complex things where they also use it, for example, at Google for this concurrent edits on Google Docs where you can type at the same time with someone else. So share the document, you type at the same time, you see them typing. If they don't have access, or if you remove access for them, then they also deal with concurrency in terms of they're not allowed to see anything after they've been removed from the document, for example. So they also need to keep track of timestamps, and also, so they have special tokens and so on. Actually, very cool thing, but it's kind of a different approach. So with OPA, we try to have everything kind of declarative. So you say, this is the policy, and then you check against it. And this is more imperative if you think in terms of programming languages. So you say, this person has access to this resource through this role with these conditions, more or less. But it has a cool playground, so you can Google SpiceDB, you can go on their webpage, and you can try out how the language works. And you can see a graphical representation of how it works and what it does. Next topic I have is Vault. So Vault, or now I guess OpenBAO is the proper open source version, is a secrets manager, but actually it has some very cool features. So it's not just a key value store where you can, I don't know, put a secret in and then fetch it. It has a bit more to it. So one thing, for example, that I really like is this dynamic database credentials feature. So essentially the way it works is you have some root of trust. Let's say we have our workload identity for the sake of the conversation. You use that to authenticate against Vault. Vault checks, so identifies you with authentication, checks the internal permissions. So it's configured to have certain permissions. So it authorizes you. If it agrees that you have access to the resources, it will return a vault token for you. So first you get a token. This token is assigned a lease, so a time to live essentially. With this token, you can make another request to Vault and ask for database credentials. Vault will at this point make a call to Postgres in this example. It will create dynamically a user and a password for you, and it will return this user and password to the user or to the workload in this case. Why does it create dynamically a user and a password? Essentially, the idea is the username and password is bound to the lease of the token, so the time to live, which means if the pod spins down, you don't need to do any cleanup. Vault will just notice that it has expired. It will make a call to Postgres. It will delete the user. It will delete the password. It will be gone like it was never there, except for auditing, of course. The whole purpose of it is to make sure that you don't end up with some usernames and some passwords that are lying around, but really that after a while they just get cleaned up automatically. There is another benefit to it. Essentially, since every workload, so every pod gets its own identity, you can in the database have a separate user for every pod, even of the same application. So as you scale up, you have 3 replicas, you can have 3 different users in Postgres. Benefit here is if you suspect a breach in one of the pods, you can just terminate that user and you can have the others running and therefore try to reduce disruption to the system. Whether this is something you want to do in a critical situation is a different story, but it is an option that you have. So in addition to this, they also have several other secret engines. So they have something for example, for Google service accounts, where instead of creating a service account key that lives forever, you can ask Vault for a service account key. It will call the Google API, get a service account key, give it to you, bind it to the lease, and when the lease expires, call the Google API and delete the service account key. This is a nice feature, especially since Google does not have an expiry on keys for service accounts. It can also dynamically create service accounts. It can also do a lot of other things. It can also do key value secrets, so the simplest form. Yeah, the rest of the things, in the interest of time, I will briefly go over, but essentially with MTLS, you can have something like Istio, so a service mesh is much more powerful and much more complicated or dangerous than just MTLS, but it allows you to essentially have sidecars next to your pod, route all traffic from the application to the sidecar, and then ensure that only traffic between, so within the cluster, only traffic between designated pods is allowed, so designated services, and this is protected with MTLS, so mutual TLS, so that you cannot snoop the traffic within the cluster. And in addition to this, it can also take care of ingress traffic, egress traffic, so it has a bunch of other rules that you can have in place, and we even have it configured, for example, to reach out to Keycloak and check also for identity tokens for users that try to call, so bearer tokens for users that try to call the service, and reject users that are not authenticated with Keycloak. There you can also have certain authorization policies, so you can say Keycloak needs to provide in this token a set of roles, and if these roles are there, then I allow access to endpoints on my service, otherwise I will not allow it. So then we have image scanning as the next kind of level of security. So here we move more towards supply chain security. This is also a topic that I guess for Christoph was kind of relevant. You can have image scanning. You can have this as you deploy images to the cluster or as you build images, check for vulnerabilities. If an image is vulnerable, ideally you don't want to deploy it to the cluster. How do you make sure that an image was scanned and only images with an acceptable level of risk were deployed? That's where image signing comes in. So in addition to scanning, you also want to ensure that the scanning was done properly and actually the image that you're deploying is the one that you scanned. Here you can have a tool such as cosign, which essentially verifies, issues and verifies cryptographic signatures on the images. This can also be a bit tricky. So we learned last week, 2 weeks ago, when Docker further reduced their rate limiting, that cosine actually, if you give it a tag image, will pull the hashed image, because obviously verifying signatures only makes sense for hashed images. It will pull the hashed image bypassing the node cache for the images, which means we hit the rate limit for Istio images, and then we had an outage in the cluster. Long story short, be careful with it. Make sure that if you have it properly, that you know what it does. I also have an honorable mention with ChainGuard. I think, as far as I know, there is no free version of it, but they really try to make sure that they have these super secure images with zero vulnerabilities and properly signed, and make sure that they have no unnecessary executables in the images. So if you're building something super secure, then maybe worth looking into. And finally, we have other open source tools like Falco, where you can have really real-time threat detection. So essentially, it has different plugins for the different parts of the systems, system calls, audit logs, so on, and it tries to in real time monitor the usage and detect any anomalies and alert you on what it believes to be security threats or exploits that are ongoing in the cluster. So how does this look in real life? I mean, I have two views of it. One is an application that we've built, which looks much more complex, but is actually not that complex. Essentially, what we have is a client that comes in to our front end. So the whole application is kind of multi-tenant aware. The client comes in to the front end, gets redirected to Keycloak, needs to authenticate. In Keycloak, we have different realms for the different tenants, where the tenants can configure their settings. So the administrators, the client will get a job from Keycloak, which contains the realm ID and other information. It is then in the backend, so in the application container, we can use the client token to go to Vault and fetch a Vault token. So essentially, we say we don't want the machine to identify itself against Vault, but we want the user to identify themselves against Vault, because the machine cannot really know which tenant the user comes from. And even if it does, the tenants don't trust each other and don't trust the machine. So they want to make sure that it's impossible. So it's about financial data, and they want to make sure that it's impossible that company A sees the financial data, the payment data of company B. So essentially what we say is it will be impossible because the tenant is bound to the access to the database. So when you make the request, you're given a token. This token only has access to one of the two databases. It's not possible to share it. So the application makes a call to Vault, asks for a database credentials, we'll receive them, and then based on this, we'll configure Hibernate and Spring Data to essentially go to the correct database, connect to it, do the transactions, and then expire or revoke the Vault token and therefore revoke the database credentials. I mean, in addition, we also use this transit secret engine, which is essentially useful to encrypt data in transit. So the data that we get from the database, we make a call to Vault, Vault encrypts it for us, and then we can send it through the RabbitMQ, so ActiveMQ, so through the eventing system to another application that will then process the data. And yeah, essentially we have monitoring like good developers. So not that complex, but a lot of effort went into this tenant separation and thinking about and proving that no tenant can see the data of another tenant. The next use case is a bit more complex, even though it looks a bit simpler on the diagram. So this is a developer platform for a client where, again, it's a multi-tenant setup. In this case, it runs on Google Cloud, where essentially developers belonging to different teams are allowed to deploy their code, their workloads. And essentially, they get a namespace to deploy the workloads that they have. And with this namespace, they get connections to databases, they get connections to Vault, they get connections to Keycloak. Active Directory, of course, is involved. And the trick here is how do we make sure that we have, again, this tenant separation, especially since There are some laws in place that need to ensure that some things are strictly separated. How do we make sure that this whole thing can happen on a large scale and automatically? So we are talking about something like 600 developers that want to dynamically spin up and spin down services. And essentially what we did is we said, okay, we will pull the information from Keycloak, which can then use identity federation with Active Directory, with Google identities, and also with what they call ZBS, so Central Berechtigungssystem. It's an Oracle database. But essentially, it will pull all of this information into Keycloak. We have a simple interface. We go to Keycloak. We ask, is this developer allowed to access certain namespaces? In this namespace, every pod that gets provisioned gets a workload identity, so it's bound to a Google service account, which can then be used to access Google services and to authenticate against Vault. And through Vault, it can have access to a database, for example. In addition to this, we have a lot of kind of side things. So Istio is in place to ensure MTLS between the services. We have a different kind of setup for customers and not developers. So obviously developers need to deploy, but customers need to access the service. So there's a different setup there, especially since we also need to support different URLs, which is not that simple from the Google infrastructure. So in the end, it turned into a much more complex project. But again, just by leveraging the tools that I mentioned before, we were kind of able to, and some paid alternatives like workload identity, we were able to kind of ensure some sort of security and separation between the tenants, and also pass some security audits. So you don't have to take my word for it. There's also a paper that says we did it. If you're curious about more details, you can find me after. I think I'm right on time. So thanks a lot, and any questions? Yes.
Yeah, not really a question, but in addition to Trivy, we use it not only for dependency tracking and tracking vulnerabilities for dependencies, but also, as you said, for Docker images, Docker containers, and there is also an OpenShift operator for Trivy that scans your whole cluster resources and gets your vulnerabilities for that also.
Do you use it then to feed it to the tool that you showed us?
Right. So we just generate the SBOM, and the tool dependency track uses Trivy behind. So
have you tried Sneak and other kind of vendor?
Not Sneak, but Sift, and we generate the SBOMs with Cyclone DX.
Yeah, most of them are using Cyclone, and seems to be pretty standard and working well. Other questions? Yes.
Awesome talk. It was very insightful. I really liked it. One question, like in this, you have like the traditional approach where the developers, I guess, push their or have their. I'm not sure how the workloads then end up in the cluster.
You mean here?
Yeah. So is it like, do you have like a GitOps approach?
We have GitOps. So back when we started the project, this was I think 2019, 2020. Even from the start, we made the decision that the cluster is completely shut down. There is no access to the master plane, and we only allow GitOps. Over time, some platform maintainers got some privileged access, but also this is something that happened after I left the project. So I was very strict in my time. We started with Flux CD, so the first version of Flux. It was terrible. It was terrible because it required an installation in every namespace. So at some point, we had more resources on Flux than we had for the rest of the system. We switched to Argo CD because Flux v2 was not ready at the time. So I cannot compare Argo CD with Flux v2, but I can tell you that it's much better than Flux v1. Yes?
Maybe a follow-up question to that. You explained earlier with the permission system. I'm not sure which one now you exactly use. did you tie in the permissions who can deploy what resource with the GitOps approach somehow? Because like that's outside of the cluster as well.
We
Trust.
no, it's restricted. So we every time a team onboards, let's call it, they get the dedicated GitOps repository only for them, and this can only deploy to their namespace. And then we tell the team lead, you're in charge of who can access this repository, and it's your responsibility. So at that point, so when a team onboards, we run some workload, some workflow operator thing, which instantiates this repository, assigns a team lead, and then from that point on, we basically give the key and tell them this is yours now. Doesn't always work, so sometimes they come back, but yeah, that's the general idea. And then there was a major problem, for example, because everything was pretty restricted. There was a team that wanted to access production services from development, and this is still an ongoing fight because they believe this is necessary. We believe this is not allowed. So
do you have a break class process in place? Like that's one way usually to approach.
There is so now Google has this thing called PAM, Privileged Access Management, where you can assign a list of people that have privileged or could have privileged access with the permissions that they need. And then if they need this, they can go to this tool, open it, write down a reason why they want it, and then it can be auto-approved basically. So nobody approves it, you just for auditing purposes write it down. Then you get privileged access for a limited period of time. When we were designing this tool didn't exist. We used an open source tool, but I'm not sure what it's called. And essentially it does the same thing. So it has, of course, it cannot go to the Google API, so it has a privileged service account key, which you have to type in why you need it, and then you get it, and then it gets rotated the next time. Yes?
Does your security concept look the same for your dev environment and for your production environment? Or do you have more loose standards like access to the cluster namespace as well for dev systems?
The only difference between the dev environment and the prod environment, as far as I'm aware, is that on the dev environment, developers can get credentials to the database and connect their local setup to the database. Yes?
How do you keep all the tools up to date?
That's a good question. So for the tools that we have for the platform itself, we have regular maintenance windows where we essentially update. We also have renovate in place. For the applications themselves, they're the responsibility of the application developers. However, we also have renovate in place for them. We send them merge requests. Some get merged, some don't. Yeah. Yes.
I mean, you showed a lot of open source tools, a bunch of them from CNCF, which, by the way, I set up a desk with stickers there.
Nice.
But do you get any resistance from customers, like, hey, this tool is open source, I don't trust it, or?
Not really, but in some cases. So how to put it politically? There are different... So for our biggest customer, the organization is split between Germany and Austria. And in Austria, they're perfectly fine and enjoy open source tools. And they, obviously don't want to throw money for no good reason. In Germany, it's the reverse. So the first thing, when you pitch a tool, the first thing they say is, does it have a license and where can I sign? And it's a different mindset, I would say. But yeah, essentially, it's in Austria, at least for the customers that we also for the this is a German company. It's a treasury management company. They were perfectly fine with open source tools. Also, the Vault that we use is the open source version, not the enterprise version. They did, however, ask for certain, let's say, guarantees. So for Vault, for example, we had to check that it had passed audits, and obviously the CNCF tools, especially the security-related ones, have external audits that you can look up and use. And here it was, for example, everything you see there, the Vault installation, the Keycloak installation, that's all open source. Workload identity is the standard Google tooling because it came for free, so there was no reason to use an open source version. But I would say, at least on the platform side, 80% of the time we went with open source tooling. Then, thank you very much.